In this question, we've been told that in a histogram, the weights of baby hamsters, correct to the nearest gram, are plotted on the x-axis. So we don't have the histogram itself, but we've been given this information about the context of the histogram. Something that's very important is to notice that each of these are correct to the nearest gram. These have been rounded to the nearest integer. In the next sentence, we're told that in this histogram, the class 24 to 30 has a frequency of 63 and is represented by a rectangle of base 2.8 centimeters and height 6 centimeters. I'm going to represent that, remembering these have been rounded to the nearest gram. So instead of 24, I know that the lower boundary is 23.5. And instead of 30, I know the upper boundary is 30.5. This is what we would have had before we rounded. Okay, so that means the class width, this is why it's important to use the boundaries, the class width is the difference between these, it's 7. But the drawn width, it was drawn 2.8 centimeters wide. That means there's a scale factor of 0.4 from the class width to the drawn width. Frequency density, we were told the frequency is 63. Frequency density is going to be the frequency divided by the class width. 63 divided by 7, and we get 9. Referring back to the question, the actual drawn height was 6 centimeters. So I need the scale factor from 9 to 6. 6 is 2/3 of 9. So I know 9 times 2/3 will get me that 6. Now that I have these two scale factors, multiplied by 0.4 and multiplied by 2/3, I can make use of them with any bar of this histogram. So the very next sentence tells me that in the same histogram, the class 31 to 35 has a frequency of 60. And we're asked to find the measurements in centimeters of the rectangle that represents 31 to 65. First things first, let's get the class boundaries, remembering to use 30.5 and 35.5. That gives us a class width of 5. Apply the scale factor of multiplying by 0.4, and we know that the drawn width is going to be 2 centimeters. Moving on, there's a frequency of 60. Frequency density, that's going to be our 60 divided by our 5, which gives us 12. Same scale factor, multiplying by 2/3, gives us a height of 8 centimeters. Okay, so there we go. Making good use of the scale factors that we found in the early part of the question, we can find the dimensions of any bar that we're given.